Hey guys, Miss O'Malley here. Let's go ahead and go over this Watersheds assessment, and then you can make corrections on your test, and then go through and work through the relearning practice worksheet, and then we will go ahead and retake the test. So first question here, so a watershed is best described as, and the correct answer for this one here, guys, was B, so an area of land, okay, that drains into a common body of water, okay. I think the most common incorrect answers I saw were A and D. But the correct answer is any area of land that drains into a common body of water. All right, let's look at question 2 now. So label the numbers on the diagram as surface water, groundwater, or neither. So first we're going to look at number 1 here. Okay, so number 1 is the surface, ground, water, or neither. So is this water underground or is it on the surface? And the answer to this is neither. So this is water vapor specifically. Okay, so that's water in the air, and that's not on the ground. It's not on the ground, or it's not in the ground, rather. And then we're looking at number 2. Okay, so number 2 is precipitation. All right, and while it's still precipitating, okay, so while that rain is still rain, all right, it is not surface water or groundwater. But once that rain hits the ground, it becomes groundwater, okay? So number 2 is also neither. Number 3 is right here, and that's representing this little like lake kind of in the back here. Not sure why that erased, but so again, that little lake in the back, and that is going to be surface water. So that's water that we can like see on the surface, right? So those are lakes, streams, the ocean, ponds, okay? So that's surface water. And then number 4, representing a larger body of water here that this stream is flowing into. Again, that's also going to be surface water. And then finally, number 5 down here. So this number 5 is representing this water, okay? And this all under here, okay? That is all groundwater. All right. So let's look again at number 3. So it does require us to look at the diagram above. So I'm going to go ahead and erase my little notes here so I can walk you through. And then, all right, so in the diagram above, so again, this diagram here, all right, how can the water in label 1 turn into the water in label 5? So again, we're looking, how can 1 here turn into 5 here, all right? So this really goes back to also to learning about our water cycle. Now, if you're someone who put like the water cycle, well, yes, but you need to elaborate, okay? So number 1, so this is water vapor, okay? So number 1, so water vapor condenses into clouds, and then it will precipitate. So remember our precipitate, so you could have said it will rain or snow, okay? Leading to, so right now we've gone from 1, we've got clouds, we're going down through 2, okay? So once that hits the ground, okay, So once again, this rain hits the ground, it becomes groundwater. It's going to become runoff. And some of this water that hits the ground will infiltrate. Okay, so this is this step right here. All right. So remember our term infiltrates from water cycle. Okay. So some of that water will infiltrate into the groundwater table. So I was looking for something along these lines, but really the three big things that I was looking for with number 3 was 1, saying it's going to condense into clouds. 2, it's going to rain or precipitate, and 3, some of that's going to infiltrate or soak into the ground. So really, those were the 3 big things. If you summarize like these 3 things in some way for number 3, you should have been good. All right, guys, so let's go ahead and flip over to the back and look at number 4. So this is one that I saw quite a few errors on. The biggest one, or one that like really stood out to me, was a lot of you guys like talked about these boreholes. So you looked at this like legend or key here and we're like, boreholes, that seems important. Even though we've at no point talked about those in class at all. And so I'm not sure why you guys thought that that was super important. But if you talked about that, didn't know that had nothing to do with this answer. So looking at number 4, so each half of Mount Ketlinski feeds into 2 separate watersheds labeled A and B. So again, we've got A over here is this side, and we've got B over here. Okay, so A or B and then A. How would different sides of the mountain differ in their water flow? So really what I was looking for is for you to tell me that side A, okay, so side side A is much more gradual in its incline or steepness. Okay, so really side A is less steep. Okay, and because it's less steep, the water's going to flow slower than it would on side B. So side B is much steeper. Okay, and so side A would flow much slower than side B. Or you could have said water would run off more quickly on side B because it's steeper. Okay. Now, how we know that side B is steeper. So again, looking at our, and guys, sorry, feel free to pause at any point to make your corrections. But looking at this map here, because you guys will need to do this on the retake. So how we know that side B is steeper, okay, is because these contour lines, okay? So, and all these lines here, let me change my color of my pen real fast. So all these individual lines here, so I'm just tracing in the upper right-hand corner. Each of these lines, guys, that's called a contour line. And what that shows is an increase in elevation, okay? So each one of these lines shows an increase in elevation. Now, looking at side B and side A, okay, we've got this mountain, all right, and because the lines on side B are much, much closer together, okay, that means that it's a lot steeper, okay, than side A, whereas the more spread out the lines are, okay, like they are on side A, that's a much flatter, it's a very gradual change in elevation. So the closer equals steeper, okay, so the closer these lines are, the steeper that elevation changes, okay. So this essentially indicates steepness of the hill. All right, and then finally we'll move down to our mastery question number 5. And I realized when I printed out the copies and made the copies, the picture was kind of hard to see, but you guys did read about this, and I did kind of describe it here a little bit. So in an area known as Mud River in West Virginia, has been strip mined, pictured left, resulting mountaintop removal, flattening the land. How will this strip mining affect how water affect the flow of water in this watershed? I also accepted a couple answers where if you talked about like the pollution, because you guys did do a reading about strip mining and how it affects pollution. If you did talk about that and talk about how it's going to pollute the watershed, because that can affect the flow of water, I did accept that as well. But strip mining, the first thing, so what the strip mining does, right, it tells you, so it kind of flattens the land, and literally what it does, it's like, oh, like this, so this is all this area, okay, so you can see this here, whoops, is the same point as this point here is the same point as this here. So what this does is they literally like carve off the tops of these mountains, okay? And so what it's going to do, because it changes literally the topography of the land, okay? So your first response answer that would have been acceptable was because strip mining flattens the land. It will change how water flows in the watershed. And a lot of you guys cited like it may, so it can dam streams or rivers sometimes. So if there's like a river flowing through, so you can almost see one like right here. What it'll do sometimes, it'll literally like dam it up. The second answer that I said that could have been accepted would be that the loss of vegetation would result in more runoff, okay, because the vegetation would not absorb the precipitation. All right, so that second one, you could have talked about how this would affect the precipitation. or rather not the precipitation, but it would affect the runoff, okay, in this, because it's going to increase. And then the other one that a lot of you guys talked about was that essentially going along with this like loss of vegetation. So going along with that loss of vegetation, it would result in like the waterways becoming polluted. So sorry, I'm at the bottom of my page here. So the watershed becoming polluted from that mining operation was also an answer that I would have accepted from you guys. But as you go through and work through the remaining parts of our retake worksheet, guys, so remember that there are other ways that watersheds can be affected. Looking at this mastery question here, so some other of the readings that we did. So we talked about mining. I believe another one that we talked about was like the clear cutting of forests and like logging. I'm trying to think of some of the other ones we talked about. I think maybe we did a reading on agriculture as well. Make sure that you take a look at some of our topographic map notes. Okay, going back to number 4. Remember, so surface water, that's anything that, like, if you're standing outside, you're going to be able to see. Groundwater is anything that is underground, so it's being stored underground in something like an aquifer. And if it is in the air, it is not groundwater yet. So remember, our precipitation and our evaporated water vapor, that is not, that is neither groundwater or surface water. And then remember, a watershed is an area of land that drains into a common body of water. All right, guys, so go ahead, scroll back to wherever you need to make your corrections for this test, and then work through our worksheet, and then we'll be retaking this test. I will see you all in class very soon.